Hey everybody, looking forward to the seventh game of Boston, Miami. Should be a good one. Okay, this one is from the Spanish Math Olympiad in 1996. It's a number theory problem that deals with the greatest common divisor. That's what this stands for, folks. GCD, greatest common divisor. Now, we have this kind of strange looking condition. We let A and B be natural numbers. By natural numbers, I just mean numbers 1, 2, 3, 4, not including zero, no, non-negative integers and not including zero. So 1, 2, 3, 4 ad infinitum. Now, so we have A and B natural numbers such that this condition holds. This just says this sum, the symmetric looking sum, is also a natural number. Okay, we're supposed to show that under this constraint, the GCD of A and B is less than or equal to the square root of the sum. Okay. Now this very first statement here, I'm simply just writing down more or less. I won't say that necessarily the definition, but this means D, capital D, is a divisor. It's the greatest divisor, common divisor of A and B. But divisors come in pairs, and so we get these two statements right here. A has to equal to KD, and B is equal to JD. And I just picked K and J as arbitrary natural numbers. That in a simple example is like 6 is equal to 3 times 2, which means that 3 and 2 are divisors. And that's really just a statement right here, except these values are unknown at this time. All right, now, this next part here, we're just doing some algebra, okay? Just doing a little bit of algebra. And right from here to here, we just use these substitutions, right? These substitutions are what happened from here to here. This piece right here is just common denominator, and you can kind of see what happened there. It's fairly straightforward, about one step, and then you bring a D down basically to clear things out. Technically you would get a K squared D squared, but if you bring one of the D's down, that just becomes K squared D. All right. Now notice here that this piece right here is still a natural number. Okay, this is still a natural number. So I'm going to go ahead and write it. That's by supposition, right? That's by just supposition at the beginning by the premises of the problem. That expression, this entire expression, is still a natural number because all we did was re-express this in terms of these substitutions. Okay. Now, for that reason, D has to divide this number. D is in the denominator here, and it has to divide. The numerator. D is already here and here, but it also has to divide K plus J in order for this to be an integer. Okay, or a natural number, excuse me. And I hope that makes sense because K plus J would have to be divisible by D, or this expression here would not be divisible by D. All right. Now, the reason why that's important is because a divisor is also going to be less than, okay, what it's dividing. And so what I did here, just looking towards what we're looking for as the answer, D would be less than or equal to K plus J. I left that step out and went ahead and multiplied by D to get this statement. So I did leave out, this directly implies that D would divide the quantity K plus J. All right, well, if you multiply by D, you get this. And why do we do that? Well, we know what the answer is supposed to be, right? It kind of can cheat here a little bit. So we take the square roots of both sides and we get this truth right here. And then D times K plus J is actually, if you take a look right here at these definitions, folks, it's D times K plus J. Well, K, I'll just write off to the side here. K is just, K is equal to, from here, y'all, K is equal to A over D, right? K is equal to A divided by D. And again, y'all, all I'm doing is just rewriting this piece right up here to show you why this has to equal to this. And then also, what do we have here? J is equal to B divided by D. So J is equal to B divided by D. Okay. Now, you probably didn't need to see that, but that's exactly why K is equal to A over D and J is equal to B over D. you can see exactly why this product has to be equal to a plus b. Okay, so y'all, that's the proof finished. And by the way, this proof was unmotivated because what I did, there's no way I would have known to start it this way. I played around with various numbers that met this condition. You know, I chose A's and B's that satisfied this condition and played around with it numerically. And I had to do 2 or 3 or 4 examples before I saw this would be a good approach. I would have, unless I'd done something numerically, done a few trials, no way I would have known to take these steps.